this video we're going to be talking about solving absolute value inequalities when they're in the greater than form. That means that once we've already isolated the absolute value, it ends up being greater than or even greater than or equal to a value. Now again, I think it helps to start off with an image of this and what that means. So if I have the absolute value that is greater than or equal to some number, that means I want all the distances that are greater than or equal to 5 units away. And in this case, because it's just x inside the absolute value, that means greater than or equal to 5 units away from 0. So if I put 0 here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, this would be the negatives, positive direction. If I want a distance greater than 5 units away, that would start at 5, greater than or equal to, so that starts at 5, including 5, and then everything going further away from 0. All of these distances are greater than 5 units away. Same thing down here. I'm starting 5 units away. Now it's in the negative direction, but still 5 units away. And I want all the distances greater than that, so even further away. So when we have an absolute value inequality, it's going to end up looking like this, like a disjunction, as we may have heard or seen in previous videos. So that means that's going to be an OR statement. The solution set is over here or over there. They're separated from one another. So when we go to solve these absolute values inequalities, we have to think of all the things getting bigger in the positive direction or in the negative direction. So I have to solve them as two separate inequalities. So again, our first step is to isolate the absolute value. So in this example, I already have it isolated. And then what's inside the absolute value could be all the distances greater than 3, right? So that'd be 3 going up forever. Or what's inside the absolute value could be all the distances less than negative 3, right? So we had our positive and then our negative, and it's going to be everything less. It's going left, it's going down. So that's why I have to flip the direction here. Also, I've added a negative, so it flips the direction of my inequality. Okay? And then I solve these separately. So subtract 2, subtract 2. And I have x is greater than 1, or x is less than negative 5. I want to graph this on my number line. I'm going to plot my negative 5, 0 somewhere, 1. So greater than means getting bigger, going up in the positive direction. There's no equal to bar here, so I'm going to use a parenthesis. You could also use an open dot. And greater than, I shade up. Or the solution set is down here. It says x less than negative 5. So less than, I shade left. And again, it's not equal to, so I use a parenthesis or an open dot. If I want to write this in interval notation, I start from left to right of my graph. So this is going down forever. So I'm starting at negative infinity, going up to negative 5. Union, remember OR is another word for our union statement. Starting at 1, going up in the direction of positive infinity. And that's our interval notation. So you're always going to break up a greater than statement into an OR statement. The solution is here or over there. Again, because it's greater than, the distances are getting further away from wherever we're starting at. Let's look at another example. Down here I have the absolute value of x plus 1 plus 11 greater than or equal to 9. Now again, I have to isolate this absolute value. I start by subtracting 11. So absolute value of x plus 1 is greater than or equal to negative 2. So now when I look at this, I want to think about my absolute value and this negative number that I see. An absolute value will always be positive. Right? So once I take the absolute value, it'll be positive. And I want to know when that's going to be greater than or equal to a negative number. So again, after I take this absolute value, I end up with something positive. When are positive numbers greater than negative numbers? They're always going to be greater than negative numbers. So this is always true. This is all reals. Anything I plug in there for x is going to make it true. In interval notation, that would be negative infinity to infinity. On a graph or a number line, it'd be everything. And if you forget this, if you forget to look for those negatives, you could also go ahead and keep solving with the one statement or flip the direction, change the sign, the other one, but then you'd end up shading everything. You would see that you'd end up shading everything up and then everything down. And since it's an OR statement, the union, we take everything that we've shaded, which is everything. So if you forget, you can still get the same answer as long as you realize that a greater than is going to be an or a union statement, a disjunction. Alright, go ahead and try the 2 on the right. Alright, looking at this example on the right, I have the absolute value of 2x plus 3 minus 9 greater than or equal to negative 4. So you might stop and say, uh-oh, there's negative. I don't have to do any work. I can just go to no solution or all reals. But that's not true. Right? I have this absolute value. It is not isolated yet. I need to add 9 to both sides. And that says the absolute value is greater than or equal to 5. So it's no longer negative. And I can keep going. I need to keep going to solve. So I have a greater than, so I know it's all the distances greater. They're going further away. So I take what's underneath, inside the absolute value. I set it greater than or equal to positive 5. And then the 2x plus 3 less than or equal to negative 5. So again, greater than for the going up, less than for the going down. I flip the direction of my inequality to get that negative number. And now I can solve them, keeping in mind this is an OR statement. The solution's over here or over there. So I start by subtracting 3 from both sides. I have 5 minus 3 is 2. And over here I have negative 5 minus 3 is negative 8. And when I divide by 2, 2 divided by 2 is 1. Over here, negative 8 divided by 2 is negative 4. So I need to graph this on a number line. I have a negative 4, a positive 1. This says x is greater than or equal to. Since I have that equal to bar, I use a bracket or a closed point. And greater than, I shade up. Here I have x less than or equal to negative 4. Less than, I shade down. Because of that equal to bar, I use a bracket. Again, I read this from left to right when I write my interval notation. So going down further, that means starting at negative infinity up to negative 4. I use a bracket, union, bracket, 1 to positive infinity, going up forever. And there's my interval notation. Alright, one more here. You might say, wait a minute, this is a less than, what's it doing in this section? My answer is, start by isolating that absolute value. So I subtract 5 from both sides. Don't lose this negative. It's the negative absolute value of x minus 4, less than 2 minus 5 is negative 3. Then I still have this negative here, right? This is like a negative 1. So I divide both sides by negative 1 to get that absolute value totally alone. Now I have divided by negative. I need to flip the direction of my inequality. A negative divided by negative makes a positive 3. And I end up with the absolute value of x minus 4 greater than 3. So this is in the form of a greater than problem. So greater than, I know this is going to be an or statement. It's going further away from my starting point. So I break it up into two statements. X minus 4 is greater than 3, or x minus 4 could be less than negative 3. So all the distance is going up from positive 3, all the distance is going down from negative 3. I solve for x. Add 4 to both sides of my inequality. I get x is greater than 7, or x is less than negative 3 plus 4 is a positive 1. So now I keep going, I graph. I plot 1 and a 7. Greater than 7, no equal to bar, I'm going to use a parenthesis. Greater than, I shade up. X less than 1, so no equal to bar, I use a parenthesis. Less than, I shade down. And then in interval notation, it's from negative infinity up to positive 1, union, starting at 7 and going up forever. And there's your interval notation. You may have tried to stop here and said, wait a minute, there was a negative, and I stopped, and I thought it was going to be all reals. Well, we still have this negative out front of the absolute value. It wasn't alone. So you had to divide by that negative 1 first, and then you can evaluate the solution going forward. Was it a less than form? Is it a greater than form? Was there a negative or not? And in this case, there wasn't a negative. Once the absolute value was totally isolated, there was no negative. And we ended up with this union. Alright, I hope that helps.